Tuesday of week 8. Okay, so what this problem really was about is gravitational potential energy. But what I tried to sort of drive home here is that what gravitational potential energy really means is that the work done by certain conservative forces can be written as the change in some function. And it's this function that we then name gravitational potential energy, or spring potential energy, or magnetic potential energy, or whatever it might be. And so the work that's done by gravity, say as an object is falling downward, the work that gravity does is the force, which is mg, times the distance over which it falls, so maybe mg h. So in this problem, you can do this problem all sorts of different configurations. But the idea is that the only thing that matters is the work that's done by gravity. The normal force does no work. And in fact, even if the ball doesn't go straight down, but the ball, say, starts here and then goes downhill even at an angle, and maybe there's bumps and loop-de-loops, it doesn't really matter actually. Because of the dot product, this height is only the distance that matters. And so in fact, if you know, say, this, say y1, y2, or y3, what you can say is that the kinetic energy plus this potential energy at 1 is the same as it is through the whole path. And so let's say you start off at the top of the hill with some speed v. Okay, so we have some v initial, and you have some mass. Okay, so the kinetic energy is 1/2 mv squared, and I can pick the potential energy function to be 0 wherever I choose. So let's choose y equals 0 down here. The only caveat here is that if you're going to write mg y has to be positive upwards. Otherwise, things would slow down as they fall, and that's not what happens. So this is, say, v1 and y1. And that equals 1/2 mv2 squared plus mgy2, and that equals 1/2 mv3 squared plus mgy3, and so on and so on. And so the first question is the speed in the valley. And so that, well, we'll just solve for v2. And so I write 1/2 mv1 squared plus mgy1 is 1/2 mv2 squared plus mgy2. I'll divide through by the m's. I'll multiply through by 2, and so I get v1 squared plus 2g, and now I'm going to bring the y's to the same side. y1 minus y2 is equal to v2 squared. And so if I square root that whole thing, that's v2. Now here's something I want you to notice. I want you to notice that it looks a lot like the kinematic equations, which is good, because we know that those are true for, say, simple things like just falling downward. But notice that this is much more important in some sense than that, because this is including for any path, not just, say, a parabolic trajectory. For any path, in fact, we can find the speed. I also want you to notice that it's sort of like budgets, right? So you can do things like, savings plus checking. And unless you spend money, those two things are going to be the same. And so in this case, what we've done is we've taken some of our savings, the mg delta y, and we've converted it into a new kinetic energy. So that's really how the theme of these problems, so we're never really going to look at what the potential is, but how the potential changes and how that is a kinetic energy. And to illustrate what I mean here, let's look at the next question. So the next question was, does it make it to the top of the hill? And so that question really says, can I take my whole savings and checking and convert say to all savings? Okay, so we're going to find out. We're going to say if it makes it, so yes, if 1/2 mv1 squared plus mgy1 is equal to, now if it's all potential, if it just makes it, that means that the velocity at the top is 0. And so it's 0 plus mgy3. And so what we mean by this here is that if 1/2 mv1 squared plus mgy1 minus y3 is, so if the initial energy is, say, greater than or equal to what it needs to get up, so greater than or equal to 0, notice that this is actually a negative number here. So y1 is smaller than y3, and so let's write it instead as 1/2 mv1 squared minus mgy3 minus y1 is greater than or equal to 0. So if 1/2 mv1 squared is greater than or equal to mgy3 minus y1. So what is this saying? What this is saying is that you start off with a certain amount of savings and some checking. And can you take all that checking and put it into savings to make up the difference? That's really what this is saying. And so if this kinetic energy is enough to make up the difference, then yes. And that's the end.